Welcome to my class of operating system. Today we will learn about multiprocessor system. Most computer systems are single processor system, that is they only have one processor. However, multiprocessor or parallel systems are increasing in importance nowadays. These systems have multiple processors working in parallel that share the common clock, memory bus, peripheral devices, etc. Multiprocessor system is a system with more than one CPU in close communication. Processors share memory and a clock. Communication usually takes shared memory. Multiprocessor operating system refers to the use of two or more central processing unit within a single computer system. These multiple CPUs are in close communication, sharing the computer bus, memory, and other peripheral devices. Multiprocessor operating system types. Each CPU has its own operating system. The simplest possible way to organize a multiprocessor operating system is to statically divide memory into as many partitions as there are CPUs and give each CPU its own private memory and its own private copy of operating system. Multiprocessing system is based on the symmetric multiprocessing model in which each processor runs an identical copy of operating system and these copies communicate with each other. In this system, processor is assigned a specific task. A master processor controls the system. This scheme defines a master-slave relationship. This system can save money in compared to single processor system because the processors can share peripherals, power supplies, and other devices. Advantages. This model is still better than having n separate computers since it allows all the CPUs to share a set of disk and other IO devices among them, and it also allows the memory to be shared flexibility. The main advantage of multiprocessor system is to get more work done in a shorter period of time. Moreover, multiprocessor system prove more reliable in the situation of failure of one processor. In this situation, the system with multiprocessor will not halt the system, but it will only slow it down. There are multiple advantages of multiprocessor systems. It is more reliable system. In a multiprocessor system, even if one processor fails, the system will not halt. This ability to continue working despite hardware failure is known as graceful degradation. For example, if there are 5 processors in a multiprocessor system and one of them fails, then also 4 processors are still working. So the system only becomes slower and does not ground to a halt. Enhanced throughput. If multiple processors are working in tandem, then the throughput of the system increases. That is, number of processes getting executed per unit of time increase. If there are n processors, then the throughput increases by an amount just under n. It is more economic system. Multiprocessor systems are cheaper than single processor system in the long run because they share the data storage, peripheral devices, power supplies, etc. If there are multiple processors that share data, it is better to schedule them on multiprocessor system with shared data than have different computer system with multiple copies of the data. Disadvantages: since each operating system has its own table, it also has its own set of processes that it schedules by itself. Therefore, no sharing of processes. There is no sharing of page file since the memory allocation is fixed and each operating system has its own page file. Also, increased expense. Even though multiprocessor systems are cheaper in long run than using multiple computer systems, still they are quite expensive. It is much cheaper to buy a single processor system than a multiprocessor system. It is complicated operating system is required. There are multiple processors in a multiprocessor system that share peripherals, memory, etc. So it is much more complicated to share processes and impart resource to processes than in a single processor system. Hence, a more complex and complicated operating system is required in multiprocessor system. Large main memory is required. All the processors in the multiprocessor system share the memory. So a much larger pool of memory is required as compared to single processor system. Master-slave architecture. A second model here. In this model, one copy of the operating system and its tables are present on CPU. Master CPU are not on any of the others. All system calls are redirected to CPU1 for processing. So this is a different type of architecture. This is a type of multiprocessor model where we call it master slave. Here, one copy of operating system and its table are present on CPU1 and not on any of the other. All system calls are redirected to CPU1 for processing there. CPU1 may also run user processes if there is CPU time left over. This model is called master-slave since CPU1 is the master and all the others are slave. There is a single data structure that keeps track of ready processes. When a CPU goes idle, it asks the operating system for a process to run and it is assigned 1. Thus, it can never happen that one CPU is idle while another is overloaded. Similarly, pages can be allocated among all the processes dynamically and there is only one buffer cache, so inconsistencies never occur. Advantage: there is a single data structure. Example, one prioritized list that keeps tracks of ready process to be executed. Page file can be allocated among all the processes dynamically since there is only one copy of the operating system. Disadvantages: The problem with this model is that with many CPUs, the master will become a bottleneck. After all, it must handle all system calls from all CPUs. If say 10% of all time is spent handling system calls, then 10 CPUs will be pretty much stress on the master, and with 20 CPU it will be completely overloaded. Thus, this model simple and workable for small multiprocessors, but for large one it fails. Symmetric multiprocessor. On this third model, the symmetric multiprocessor, there is one copy of operating system in the memory, but any CPU can run it. When a system call is made, the CPU on which the system call was made traps to the kernel and processes the system call. When a system call is made, the CPU on which the system call was made traps to the kernel and processes the system call. This model balances processes and memory dynamically since there is only one set of operating system table. It also eliminates the master CPU bottleneck since there is no master, but it introduces its own problem. In particular, if two or more CPUs are running operating system code at the same time, disaster will result. The simplest way around this problem is to associate a mutex, that is a lock, with the operating system, making the whole system one big critical region. When a CPU wants to run operating system code, it must first acquire the mutex. If the mutex is locked, it just waits. In this way, any CPU can run the operating system, but only one at a time. This model works, but is almost as bad as the master-slave model. Advantages. This model balances processes and memory dynamically since there is only one set of operating system table. It also eliminates the master CPU bottleneck since there is no master. Many parts of the operating system are independent of one another. The observation leads to splitting the operating system up into independent critical regions that do not interact with one another. Disadvantages. The hard part is splitting it into critical region that can be executed concurrently by different CPUs without interfering with one another. Furthermore, great care must be taken to avoid deadlock. If two critical regions both need table A and table B, and one of them claims A first and the other claims B first, sooner or later a deadlock will occur and nobody will know why. In theory, all the tables could be assigned integer value and all the critical region could be required to acquire table in increasing order. This strategy avoids deadlock, but it requires the programmer to think very carefully which table each critical region need to make the request in the right order. As the code evolves over time, a critical region may need a new table it did not previously need. Thank you for watching.